Assalamualaikum boys. Today I'm going to explain you the first chapter from the book, which is actually used for the preparation of Tahsili exams. So this first topic is very basic topic. I will not go in details, but I will try to stick with the basic real number properties, and then we go on to a new thing. Maybe before that you did not take the truth tables. So I will explain you the truth tables, the three statements. So maybe by that time I will explain you a little bit in detail, right? So let's start with the basic number system. Number one is, as you all know, natural numbers. It is denoted by n, and this set is 1, 2, 3, 4, and then we have whole numbers, and this set is represented by w. We just add 0, and then we go to the set of integers. It is represented by z, and it has all the whole numbers with plus and minus sign. So for your convenience I will write positive numbers on the right, they goes towards plus infinity, and negative whole numbers on the left. Some people they write it integers as 0, plus minus 1, plus minus 2, plus minus 3, like that. They are integers. So then we have another numbers which is called rational numbers. Rational numbers are represented by q, and rational numbers contains all fractional numbers, all fractional numbers like 2 over 3, 3 over 2. When I say 5, 5 means 5 over 1, 0, 0 over 1, minus 2 over 1. All numbers are rational numbers. I can say integers are rational numbers, natural numbers are and whole numbers are rational numbers. So all numbers which you took, even, odd, they are all rational numbers. I can also explain rational numbers in another way. Rational numbers can be written as terminating decimals, because sometimes fractions can be written in the form of decimals, like 2.3, 7.24, and then you stop. So this is terminating decimal, and you see that terminating decimal can be converted into a fraction, 23 over 10. So 2.3 is a fraction, so 23 over 10. Same thing, 7.24, 724 over 100. This is also a fraction. So all terminating decimals are actually rational numbers. Another one is recurring decimals. Recurring decimals, maybe you have seen 2.3333333. It keeps moving, and sometimes we write 2.3 dot. In this case you saw a block of digits, they keep on repeating after a certain number of digits, and they are called recurring decimals. Recurring decimals are also representing fractions. Like this case, I can say that it is written as 7 over 3. So 7 over 3 can be written as 2.3 dots. So guys, as you see that I can write the recurring decimals, the terminating decimals, all numbers, all fractional numbers which you have taken up till now, they are all coming under rational numbers, and it is represented by q. Then we have integers, which is represented by z, all whole numbers with plus minus sign. Whole numbers it is represented with W, just the addition of 0 in natural numbers, and natural numbers are the first numbers which we actually discover: 1, 2, 3, 4, 5, 6, 7, 8. I'm expecting that you also have an idea about some other types of numbers, like even numbers. Even numbers, those numbers which can be divided by 2, 0, 2, 4, 6, 8, like that. Odd numbers which cannot be divided by 2, 1, 3, 5, 7, like that. Prime numbers. Prime numbers. 1 is not a prime number. Yes, we have a first prime number is 2, but I write it as red. I'll tell you what was the reason for this. 3, 5, 7, not 9, 11, and it keeps moving. All those numbers which are exactly divided by two numbers, yani itself and 1. 2 is the only prime number, 2 is the only even number which is qualifying as a prime number. Then guys, this was the whole discussion on numbers which were rational numbers. Now I'm going to go to the irrational numbers. Irrational numbers. Irrational numbers are represented by I. These are those numbers which cannot be written in the form of a fraction. Most famous irrational numbers are all numbers under the radical, yani square root, but they shouldn't be a perfect square, yani square root of 3, square root of 7, square root of 11, but not square root of 9, because square root of 9 is equal to 3. So this is not the case. You can also write another irrational number, pi plus 2, any number which contains pi, but not 2 pi over pi, because pi will be cancelled, so it will not stay as a rational number. Yes, there is another famous number, e, whose value is 2.71, something like that. It's also an irrational number. It's an Euler's number. You will see this number when we revise the exponential functions. So e is very famous. Also, when I say log of 3, this is also an irrational number. By the way, when you write the irrational numbers in the decimal form, they don't repeat. They are non-terminatings, and they are non-recurring decimals. I hope you understand the real number system. Now I will draw one more thing, sorry, I forgot. Now I have rational numbers and I have irrational numbers. If I want to combine them in sets, we don't write plus sign, we use union sign. Union means like I'm going to take all rationals and irrationals. So when you combine all of them, you get a R. You get a number R, which is actually a real number. So this is called set of real numbers. So R is a set of real numbers. This is very important, that all rationals and irrationals, when you combine them, you get a set of real numbers. We have complex numbers which are bigger than real number system. I'm not going to discuss that. Next thing is, guys, the properties of real numbers. Before this, I have to draw the diagram. Remember, the first number, I'm going to write here the diagram. Diagram is, first number you saw Mr. Umar has found natural numbers. Then I found, when I added 0 in 1, 2, 3, I call that one as a whole number. Then after that, we added more numbers, negative numbers, we got integers. And then after that, we took those numbers which were written as a fraction, but they were not a whole numbers. So we call them, all numbers are coming, all all the sets, natural number, whole number, integers, they are the subset of rational numbers. Then after that we have another set of numbers which is outside, which is not a rational number, irrational number. This number is, this is irrational, which is represented by I. Collectively, all rational and irrationals, we call them set of real numbers. So if someone say 1 is a natural number, 1 is a whole number, 1 is an integer, 1 is a rational, 1 is a real number. Square root of 3 is an irrational number, but it is also a real number. But this type of a number, square root of -3, this number is not a rational number. It's not an an irrational number. It's not a real number. Actually, this is an imaginary number, and this discussion is a little bigger. I'm not going to go into this imaginary number discussion, right guys? So alhamdulillah, we discussed a real number system. Now we come to the real numbers properties. So the properties of real numbers. First property of real number is called commutative property. Commutative property over addition. And if I have a plus b, I can change their order as b plus a. This is called commutative property of addition. And also I'm going to write the property for multiplication. A times b is the same as b times a. I'm not talking about multiplication and division, just the two operations plus and minus. Second property is called associative property. Associative property needs three elements, and I write a plus b plus c and a plus b plus c, but I will change, I will just keep my focus on the order of addition. Suppose if I add the brackets here and then I add the brackets here, so this is called associative property for addition. And the same thing I can do it for multiplication, a times b times c. So a times b times c. I'm gonna write the brackets here. So this is associative property for addition and multiplication. Third property, it is very important. It's called distributive property. This distributive property, guys, it's the inclusion of multiplication and plus. So I write a times b plus c. So this is a times b plus a times c. Yani a multiply with this and this. So you get this thing. This is called multiplication property, distributive property. We have one more thing in addition, very important number, 0. 0 is a very important number in addition. Why? When I write a plus 0, I get always a. So this is called additive identity. It's not very important, but I wrote it here. Another thing, that if I have a and plus minus a and I get the answer 0, yani, so this 0 is called additive identity. So when the two numbers, they cancel each other and they give you additive identity, they are called additive inverse of each other. So additive inverse property. Another thing, the last one for the properties, 1. When I say a times 1, I always get A. So a number did not change its identity. That's why one is called multiplicative identity. And when A is multiplied with a reciprocal of that number, and they cancel each other, and you get the answer 1, which is you see a multiplicative identity, then these two numbers are called multiplicative inverse of each other. So these are the properties. Let me go through with them. Multiplicative identity, yani when I multiply 1 with any number, the number doesn't change its identity. When I add 0 in any number, so the number will not change its identity. Distributive property, in which multiplication and addition, both operations used. Associative property, in which 3 numbers used, and they have they have 2 properties, one for addition, the second one for multiplication. Commutative property, you just change the order of the elements, you use 2 elements, but there are 2 commutative properties, one for multiplication and the second one for addition. You guys saw that. So alhamdulillah guys, we discussed the properties of real numbers, which are important for your Tahsili exam, and we discussed the types of numbers. Now I come to the logic. First thing is called counter example. Counter example. Counter example. Counter example is an example in which a statement will be given and that statement will be assumed true. But you will find a particular case which will deny the fact which is written over there. So I can give you one example. Here. All prime numbers are odd. Now this is a statement. People call it statement, some people call it preposition. Okay, this is a mathematical statement. Now this mathematical statement may be true or false. Any preposition in mathematics and logics, when we assume that, it cannot be true and a false at the same time. So the statement which is in front of you guys, the all prime numbers are odd. Is it true? Or there is a counter example which you can give, and that example will make it false. Yes, I know prime numbers. My prime numbers, they don't start from 1. I write 2, 3, 5, 7, 11, 13, 17, and so on and so forth. You can see that all numbers are odd, and I am hoping every prime number will be odd, because if any number will stay as an even, then definitely 2 will be a divisor for that, and prime number cannot have more than 2 divisors. So what we see, 2 is the only number which is making this statement wrong. So I can say quoting the example of 2 will make this statement wrong. So this is called a counter example. I can give you one more example, then we go to the next. Second example is, if I say that if P is an odd prime number, keep it in your mind. If P is an odd prime number, then P plus 2 is also a prime number. Now this is a preposition or a statement. Now it can be true, it can be false. But here I'm assuming that this statement is true. In order to negate this truth, can I post any example? Okay, no worries. I know all the odd prime numbers. Shall I write them here? So I'm going to write them 3, 5, 7, not 9, sorry, 11, 13, so on. Now, he said p plus 2, so I need to add 2 into it, so 3 plus 2 will make it as 5. Yes, it's a prime number. Good. Let's go to the next. 5 plus 2, 7. Wow, it's a prime number. 7, 7 plus 2, it's 9. No, it's not a prime number. So it means this is my counter example. So I hope this counter example case you guys understand with the help of these two examples. Now I'm switching to my next next case, which is based on logics. So logic statements. Logic statements. So logic statements, basically they are of three types. Number one is called conjunction statement. Conjunction statement. Conjunction statement. Second is disjunction statement. Disjunction statement. And the third one is conditional statement. Conditional statement. I want to talk about first conditional statement. Conjunctional statement. So case is the case of intersection. Now the second case, disjunction. Disjunction case is the case of union. I will explain everything, don't worry. It's the case of union. Conditional statement is different from union and intersection. That is then statement. Any if then statement. I want to talk about the intersection case. You remember in Venn diagram when we took in IGCSE sets, intersection is the common portion. So we write it as this is set A and this is set B. We write here A intersection B. I'm talking about conjunctional statement. So if this is the statement A and this is statement B, how we write the conjunctional statement? Guys, a new terminology and a new notation I'm going to write. Statement, I call it A as a statement P, B is a statement Q, and for intersection, guys, I will use this sign, and. So P and Q. Now, if I talk about union, let me draw a Venn diagram. This is A, this is B, and I want to take the union, so I have to take everything, even the intersected parts. So this is my A union B, and if A represents a statement P, and B represents the statement Q union, we use this sign. So in Arabic this is 8, and in Arabic this is 7. Okay, so keep your focus fully on this statement. Statement P is true and statement Q is true. So I'm going to come to this situation. This is statement P is true or statement Q is true. So we will discuss all the cases of true and false statements. Now the third one is conditional statement. Conditional statement is when I say that a statement, P statement, then, this is the sign which we use, then, P then Q. So the whole thing depends on P. Here P is a statement where everything is depending. Q is an independent statement. So if P is true, definitely Q will be true. If P is false, okay, and Q is false, we want to see what will be the consequences. These three statements, guys, can be easily understood if we complete a truth table. So I'm going to explain you a truth table. Truth table. In the exam, if any question comes on statements, you can easily draw the truth table, which is very easy for you. We have a statement, what we understand, statement number first, which is represented by Q. Second statement is Q. Now what are the three operations, how we join them together? First one was my conjunctional statement. Please always write that, P and Q, and then disjunction statement, P union Q, and the other one is P then Q. So this is very, very important. Keep it in your mind, a statement can be true or false, but it cannot be true and false at the same time. So we have 4 cases. Statement T true, true, false and false, and true, false, true, false. Yani P statement true, Q true, P statement true, Q false, F true, Q false, Q true, P false and Q false. Now we want to see what happens to them. First, when you complete the diagram, guys, the top row is always with T's. So without any hesitation, complete the rest of the spaces in the first row with T. Same thing, guys, you do it in the denominator, F, F, but please don't write here F. You have to write here T. So this is the thing which you need to know. Noted. So T. Now, how many spaces left? Let's check. These spaces, guys, these spaces will be filled with F and F, and these spaces will be filled with T and T. I will write, okay, T and T. Then next is, last one, we write here T and false. Okay, let's discuss them. How did I complete this table? First, consider this one. Check. If P statement true, Q statement true, yes. If both of them are true, definitely they are true in conjunction statement. P true, Q false. If one of them is false, definitely this is an overlapping part, it will be false. False true, if there is a false inside it, definitely it will be false, because this is the overlapping situation. so the statement will be false. False, false, yes, both are false, then definitely it will be false. So guys, I think for you, this is not a problematic case, even though you can depend on your logic and complete the statement. Now come to the case for union. In union, guys, you see your P statement true, true, true or true. Any statement will be true. I will get a true answer. Look at that, guys. Second row, the P statement true and the Q statement false. One of them is true, so it is more than enough for me to have a truth. So I don't depend on both. So one of them is true, I will get a true answer. In the third row, you see FT. If one of the statement is true, I will get it true. If both of them are false, definitely I'll get a false answer. The problem happens only in the conditional statement. In conditional statement, when I say P then Q, yes. If today is Friday and tomorrow is a holiday, this is the statement. Yes, it's true. But if today is Friday, I cannot say tomorrow is a holiday. So look, this is the situation happening in front of you. That true implies the truth of the second statement. Truth of the first statement implies the false of the next statement. Problem happens when first statement is false in this situation, guys. When the first statement is false, you know the truth of the second statement is not depending on, because if I say yesterday was not a Friday, yesterday was not a Friday, and tomorrow is a holiday. Yes, tomorrow can be a holiday. Yes, it's a true statement. It's a true statement. And if yesterday was not a Friday and tomorrow will not be a holiday, yes, they are actually dependent statements, because you remember I said if tomorrow, if yesterday was a holiday, if yesterday was Friday and tomorrow will be a holiday, yes. So this case and this case are actually dependent. So you see, both of them are giving you true answers. Let me repeat, inshallah you guys will understand very well. As I said, you have 5 columns. First column is for P for Q, and then for conjunctional, then disjunctional and conditional statement. You will first complete this one, which is all T's. You will complete them, in which all of them are F's, but the last one will be T. Then you will complete this one with F, and this one with all T's, and the third, the last column will be F and T, and your whole table will be completed. This is the truth table. In truth tables, I think when you solve more questions, then you can understand more about the truth tables. Last thing, guys, about the conditional statement. Let me explore it more. Conditional statement. So conditional statement, as I said, P then Q. This P is called hypothesis, and this Q is called conclusion, right? So P is hypothesis and this is called conclusion. And I want to tell you a few more statements which can be made on the basis of conditional statement. What are the statements I can make? If I reverse the order, Q then P. This statement is called converse statement. Don't forget it. This statement is called converse statement, when you change the order of the statements. And if P implies Q, then Q implies P. This is called converse statement. Converse statement. Yes, one more thing. We have heard a lot about inverse statement. Inverse means not P. This is the statement, the similarity symbol. in mathematics we also use it for not P then not Q. This is called inverse statement. This is called inverse statement. So this is the inverse statement. Last one is contrapositive. Yani if I change the order of this not P not Q, not Q not P, this statement is called contrapositive. Contrapositive statement. So this is contrapositive statement. That's the whole discussion about the chapter number 1. Maybe later on the upcoming chapters I will have less discussion required, but here I have needed to explain you all the things about the real number system, and then later on the diagram and the properties of real numbers, then counter example. Then I talked about logic statements. There are 3 types of logic statements: conjunction statement, which is representing basically intersection, and disjunctional statement, which is basically representing union, which you took in set theory, and conditional statement, that if something is happening, can it imply the next stage? So we completed a truth table, and I gave you a way how to complete the truth table. In order to make a truth table, you have to make 5 columns: statement P, statement Q, and then yani the conjunction first, disjunction, and then conditional statement. I did it. After completing the truth table, guys, I came to the conditional statement. Few more things about it, like the first statement, which is called hypothesis, and the proven statement, the statement which is linked with it, that is called conclusion statement. If I reverse the order Q to P, then this is called converse situation. If I say not P is not applying a new not Q, it's called inverse statement, and not Q to not P is called contrapositive statement. Guys, I hope you understand the whole concept very well, but I believe me, when you solve the exercise questions, by that time you will understand the concept very, very well. Okay, thank you guys.